This is Drishti 2.4, and over a series of videos we will have a look at the new lighting model that Drishti 2.4 allows the user to use. Let's load a small data set. So this is the engine dataset here, and then pressing F2 we start with a different sort of an image. Let me just take the transfer function editor out here. What you'd be used to seeing when you load the first the volume first time is an image of this sort, where you have say ambient, diffuse and specular highlights, but with the new one what I have now is I create a light buffer and then accumulate all the lighting information into that buffer, and then apply that lighting information onto the model. So let's go through one of the very basic lighting types that Drishti 2.4 allows us. Now press tab to get those lighting parameters. So usually you would press spacebar to get the command help, so I'm pressing spacebar and you would get the normal command help. And then when you press tab you would get the dialog for the new sort of lighting, GiLighting. So tab and we'll get this lighting parameter. Let me turn off the basic light here. So what I call now as basic light is the one that you had up to 2.3.3 or 2.3.2. so that is what I call as the basic lighting. Now this one here is what I call as the GiLighting. GI meaning global illumination, so focus is to go towards global illumination, towards much better quality of lighting. So you start with the this sort of lighting. I'm pressing tab to get this dialog for GiLighting parameters, and what I have here are various parameters for the GiLighting. Let's just concentrate on this one here, the light buffer size and the AO lighting. So the light buffer size is basically the size of your light buffer. Now these numbers here, 1, 2, 3 and so on, they govern the size of light buffer you are generating for your model. By default the value is 2 here. So what I'm doing is, what I do in order to create the light buffer is take the size of your drag volume and then take this value here, basically reduce the drag volume by this size here, and then create the light buffer of that size. So for example, say your drag volume size, so your original volume might be say 1000 cubed. Your drag volume is basically the volume that I can fit in a single 2D texture map. Let's suppose that we have a drag volume of say 100 cubed, for example. Then in this case the light buffer would be of the size of 50 cubed. So this is basically half of that. If I have the value 1 here, then your light buffer size would be 100 cubed. If I have light buffer this parameter as 2, so basically half the size of your drag volume, so in your case it would be 50 cubed and so on, and then say 25 cubed and so on. So this parameter here is going to govern the quality of your light, because the quality of the light is directly related to the size of the light buffer. So based on the speed of your graphics card, the amount of texture memory that you have, you would tweak this parameter here, light buffer size. So more is merrier. So bigger the light buffer, better will be the quality of the lighting. But in most cases, half the size of drag quality, drag volume uh, serves the purpose. But you can reduce it even further, or you can take it up to drag quality. But the highest or the largest light buffer size that I have got is the size of your drag texture or drag volume. So let's start with that. So we have got light buffer half the size of the drag quality. Now let me show you what is drag quality here. Now in this case I am able to load the full volume, so your drag will be the same size here, 256 by 256 by 110. So my light buffer now will be 128 by 128 by 55 because my parameter here is 2. So this is my light buffer size, and this is the quality of rendering. If I decrease that, then this is the quality of rendering. So if I reduce it even further, then basically more and more light percolates into the volume, so the quality of your shadows go down, they become much more diffused. So we'll stick with 2 for the time being, and we can change the color of the light now. This is AO light, the ambient occlusion. Now the way ambient occlusion is implemented for this in Drishti is basically take a box of size defined by the AO size here, put it around the voxel under consideration, calculate how many voxels around in that box have non-zero opacity, and then based on that reduce the amount of light coming towards the voxel. So that's the basic idea behind ambient occlusion. So if you reduce the size of the box, then you can get much more sharper shadows or much more diffuse shadows. So as you can see here, so you can play with these various parameters for your volume and see the effects. Similarly, dark level and bright level. So dark level 0, you will have much more sharp, much more pronounced, sorry, not much more sharp but much more pronounced shadows, and increasing that dark level will basically reduce the contrast of the shadows. Similarly, if you change the bright level, then it will basically darken your model. You can also swap that. Say for example, I want my dark level to be 1 and light level to be 0.1, and you will get a different effect. So basically whatever is dark is now light, and whatever is now light is now dark. So you can play with that. Then you can also change the color of your light. Similarly, if you change the transfer function, so I have got a transfer function here, it changes straight away. AO lighting is pretty fast, it's pretty effective as well. And along with this, you can also use your normal shadows. So for example, here you have shadows, and I can press 1 to get the shadows. You can also change the so what you now get is an additional control. You can also have point lights or directional lights, which we will cover in another video, which will give you much more realistic effects. and then you can also have the diffuse and specular highlights. So all these things work along with the GiLighting. It's basically because I'm just using the light buffer and then using that information in the light buffer to tweak the final light or the final color of the voxel. You can also use depth cueing by pressing D. So this is the basic ambient occlusion. Let me also load another volume, say some medical volume, and let's see the effect on that as well. So this is human torso. So again, let me show you the difference. So that is the basic lighting here, and then this is with the ambient occlusion. So let me change the transfer function. So straight away you can see that this ambient occlusion kind of lighting already produces good images. No need to basically tweak with the lighting to get right sort of depth, increase the visibility, for example. You can change the light color. You can have different light colors. This will give you softer shadows, and the calculation is pretty fast. So let's stop the video here, and in the next video we will see point lights.